The discussion centers on National Electrical Code Section 225.39 addressing independent buildings or structures supplied by a separate service. A proposal recommends revising the text of this section to clarify its intent. The current language in Section 225.39 has been identified as confusing, leading to multiple interpretations. The proposal suggests revising the text to read as follows. Section 225.39 Independent buildings or structures supplied by separate service. Where an independent building or structure is supplied by a separate service, the disconnecting means serving the separate building or structure shall be located within or on the building or structure served. The disconnecting means shall be installed in accordance with Article 230. The core issue is the ambiguity surrounding the rating requirements for the disconnecting means at a separate structure. Some interpret it as the sum of the ratings of breakers installed in a panel or panels at the separate structure. Others view it as a rating requirement for the enclosure itself. Still others see it as the rating for the overcurrent protection device, or opt at the supply side of the originating building protecting the feeder conductors. The proposal argues that the size of the conductors feeding the disconnecting means should determine the capacity of the system. These conductors are sized and installed independently of the requirements currently outlined in Section 225.39. Section 225.36 addresses the ease of future expansion. This section aims to ensure that if a separate structure is later supplied by a separate service, the existing equipment would already be suitable for such use. These requirements mirror similar provisions in Article 230. However, Section 90.1b of the NEC states that compliance with the code will result in an installation that is essentially free from hazard but not necessarily efficient, convenient, or adequate for good service of future expansion of electrical use. The argument is that Section 225.39 does not prevent any hazard. Its purpose appears to be solely for future expansion, which falls outside the intended scope of the NEC as defined in Section 90.1. Furthermore, it is likely that if a structure is upgraded at a later date, most, if not all, of the equipment supplying that structure will be replaced due to age or fundamental changes in the building's use requiring greater capacity. Given the widespread misunderstanding of this section, if it is retained, its language should be clarified to specify which component of the system must bear the ratings listed in subsections A through D. The proposed revision aims to clarify that the disconnecting means must be rated for the ampacity of the conductors supplying the building or structure. This aligns with the requirements outlined in Article 230. The intent of the proposed revision is to ensure that independent buildings or structures have their own disconnecting means located within or on the building or structure they serve. This disconnecting means must be installed in accordance with Article 230, which provides specific requirements for the installation of service disconnecting means. The current language does not specify what type of ratings are required for the disconnecting means. The proposed revision addresses this concern. It clarifies that the disconnecting means must be rated for the ampacity of the conductors that supply the building or structure. For example, if a building is supplied by conductors with an ampacity of 100 amps, the disconnecting means must be rated for at least 100 amps. This requirement ensures that the disconnecting means is capable of safely interrupting the flow of current to the building or structure in the event of a fault or emergency. The revision also removes ambiguity regarding the location of the disconnecting means. By requiring it to be located within or on the building or structure served, it ensures that the disconnecting means is readily accessible to occupants and emergency personnel. The reference to Article 230 ensures that the disconnecting means is installed in accordance with established safety standards. This includes requirements for the type of enclosure, the method of installation, and the marking of the disconnecting means. By adhering to these standards, the risk of electrical shock or fire is minimized. In summary, the proposed revision to Section 225.39 aims to improve clarity, reduce ambiguity, and enhance the safety of electrical installations in independent buildings or structures. By specifying the location and rating requirements for the disconnecting means, the revision ensures that these critical components are properly installed and function as intended. This clarification helps to prevent misunderstandings and promotes consistent application of the NEC requirements. This is especially important for electrical inspectors, contractors, and engineers who are responsible for ensuring that electrical installations comply with the code. By providing clear and concise guidance, the NEC can help to reduce the risk of electrical hazards and improve the overall safety of electrical systems. It is important to note that the NEC is a living document that is constantly evolving to address new technologies and challenges. The proposed revision to Section 225.39 is just one example of how the code is being updated to reflect current best practices and to improve the safety of electrical installations. It is essential for electrical professionals to stay informed about these changes and to understand how they affect their work. By doing so, they can help to ensure that electrical systems are installed and maintained in a safe and reliable manner. The ampacity of a conductor is its current carrying capacity, expressed in amperes or amps. It is the maximum current that a conductor can carry continuously under specified conditions of use without exceeding its temperature rating. The ampacity of a conductor is determined by several factors, including its size, material, insulation type, and the ambient temperature. Larger conductors have a higher ampacity than smaller conductors because they have a greater cross-sectional area to dissipate heat. Copper conductors generally have a higher ampacity than aluminum conductors because copper is a better conductor of electricity. The type of insulation used on a conductor also affects its ampacity. Some insulation materials are better at dissipating heat than others, which allows conductors with these materials to carry more current. The ambient temperature also affects the ampacity of a conductor. As the ambient temperature increases, the ampacity of a conductor decreases because it is more difficult for the conductor to dissipate heat. The NEC provides tables that list the ampacity of various types of conductors under different conditions of use. These tables are used by electrical professionals to determine the appropriate size of conductors for specific applications. The ampacity of a conductor is a critical factor in the design and installation of electrical systems. If a conductor is overloaded, it can overheat and cause a fire. Therefore, it is essential to select conductors with an ampacity that is sufficient to carry the expected load. In addition to ampacity, other factors must be considered when selecting conductors, such as voltage drop, short-circuit current rating, and environmental conditions. Voltage drop is the reduction in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or not operate properly. The short-circuit current rating of a conductor is the maximum current that it can withstand during a short-circuit fault. Conductors must be able to withstand the expected short-circuit current to prevent them from melting or causing a fire. Environmental conditions such as moisture, chemicals, and extreme temperatures can also affect the performance and lifespan of conductors. Conductors must be selected that are suitable for the specific environmental conditions in which they will be used. In summary, the ampacity of a conductor is a critical factor in the design and installation of electrical systems. Electrical professionals must carefully consider all of the factors that affect ampacity when selecting conductors to ensure that they are safe and reliable. The proposed revision to Section 225.39 helps to clarify the requirements for disconnecting means, ensuring that they are properly sized and installed to protect against electrical hazards. Article 230 of the National Electrical Code, or NEC, covers services. It provides requirements for the installation of service conductors, service equipment, and service disconnecting means. A service is defined as the conductors and equipment used to deliver electric power from the serving utility to the wiring system of the premises served. Article 230 covers a wide range of topics related to services, including service entrance conductors, service equipment location, service disconnecting means, overcurrent protection, and grounding. Service entrance conductors are the conductors that extend from the serving utility's distribution system to the service equipment. These conductors must be sized and installed in accordance with the requirements of Article 230. The service equipment is the main control and protection point for the electrical system. It typically includes a service disconnecting means, overcurrent protection devices, and metering equipment. The service equipment must be located in a readily accessible location and must be protected from physical damage. The service disconnecting means is a device used to disconnect all electrical power to the premises. It must be located at a readily accessible location and must be capable of being locked in the open position. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect the electrical system from overloads and short circuits. These devices must be sized and installed in accordance with the requirements of Article 230. Grounding is the process of connecting the electrical system to the earth. This provides a path for fault current to flow back to the source, which helps to protect people and equipment from electrical shock. Grounding must be installed in accordance with the requirements of Article 230. Article 230 is an important part of the NEC because it provides the requirements for the safe and reliable installation of services. By following the requirements of Article 230, electrical professionals can help to ensure that electrical systems are properly installed and protected from hazard. Some specific requirements covered in Article 230 include the following. The size and type of service entrance conductors must be determined based on the calculated load of the premises. The service equipment must be located in a readily accessible location and must be protected from physical damage. The service disconnecting means must be located at a readily accessible location and must be capable of being locked in the open position. Overcurrent protection devices must be sized and installed in accordance with the requirements of Article 230. Grounding must be installed in accordance with the requirements of Article 230. Article 230 also includes requirements for specific types of services such as underground services, overhead services, and services for multiple occupancies. It is essential for electrical professionals to be familiar with all of the requirements of Article 230 to ensure that services are installed safely and in compliance with the NEC. The proposed revision to Section 225.39 references Article 230 to ensure that the disconnecting means is installed in accordance with these established safety standards. By following these standards, the risk of electrical shock or fire is minimized. In addition to Article 230, other articles of the NEC may also apply to the installation of services. For example, Article 250 covers grounding and bonding, and Article 310 covers conductors for general wiring. It is important to consult all applicable articles of the NEC when designing and installing electrical systems. The NEC is a comprehensive document that provides detailed requirements for the safe and reliable installation of electrical systems. Electrical professionals must be knowledgeable about the NEC and must follow its requirements to ensure that electrical systems are installed in a safe and compliant manner.